In this video, we want to solve the following exponential equations. Our first equation is e raised to the 5x power is equal to e raised to the 4 minus x power. Now you'll notice the base on the left side is e, and the base on the right side is also e. Remember, e is the number approximately 2.7. So we're looking at both the left and right side of this equation having the same base. So the uniqueness property says when the bases are the same, then the exponents will be equal. So this means we can set 5x equal to 4 minus x and now solve this equation. So we will add x to both sides, which will give us 6x is equal to 4, and then divide by 6. So x will equal 4/6, which simplifies to 2/3. So our solution set contains only one value, and the solution is 2/3. Our next equation is e to the x times e to the second power is equal to e to the fourth divided by e to the x plus 1. So now we need to use our properties of exponents to first simplify the left and the right hand side. So remember, even though there isn't a multiplication sign written here, there's an implied multiplication. So this is e to the x times e to the second. And if you remember our properties of exponents, for example, if you were multiplying x squared times x to the third, remember x squared really means you're multiplying x by itself 2 times, and x cubed means you're multiplying x by itself 3 times. So this would equal x to the 5th power, which means you really added the exponents in this case. 2 plus 3 gave us this exponent of 5. So we have to remember that property of exponents to solve our equation here. Because these bases are the same, they're both e, then we're going to add our exponents. So this becomes e raised to the x plus 2 power. Now if we look at the right-hand side of our equation, you'll notice that we have division. So we also have to remember a similar property of exponents. One that deals with division, the quotient property. So for example, if I had x to the 5th power divided by x to the 2nd power, if we write that out and expand that, x to the 5th is really x multiplied by itself 5 times, and x squared is x multiplied by itself 2 times, which would allow us to divide out some of these x's. So x divided by x is equal to 1, and another x divided by x is also equal to 1. So we're left with x times x times x, which leaves us with x to the 3rd power, which helps us remember that we are going to subtract our exponents in this case. So going back to our example, because we have division, and again, the bases are the same, we have a base of e on the top and the bottom, we're then going to take the numerator's exponent and subtract the denominator's exponent. So if we simplify that, we'll have a base of e, and that'll be raised to the power of 4 minus the quantity x plus 1. And these parentheses are really important because we have to be sure that we're subtracting the entire exponent that was in the denominator. So now we can use the uniqueness property once again, since we have a base of e on the left and a base of e on the right. Now we can set the exponents equal to one another. So that will give us x plus 2 is equal to 4 minus the quantity x plus 1. Now this is just a linear equation, so we'll distribute our negative and continue solving. X plus 2 is equal to 4 minus x minus 1. And if I combine like terms, x plus 2 will equal 3 minus x. Then I'll go ahead and add x to get my variables on the same side of our equation. So this will give us 2x plus 2 is equal to 3. Subtracting 2 from both sides of our equation. Now we have 2x is equal to 1. And finally, dividing by 2 will give us that x is equal to 1/2. So our solution set for this equation contains just the value 1/2.